Good morning, algebra class. I just got up, so I'm not going to let you see me. We are working today in my book, section 3-2, which is solving inequalities using addition and subtraction. I'm going to work in pen so you can see it. I also have to hold my own phone, so it'll get just slightly awkward once in a while. So let's start in section 3.2, objective 1. We have a little diagram, equivalent inequalities. It has the same solution. So that means if you have an inequality, you can change it or simplify it and it will be the same. So for instance, this might be x plus 4 is less than 7. If I were to subtract 4 from both sides, what do I get? X plus 0 is less than 7 minus 4, which means x is less than 3. This, is equivalent to this. We have the exact same inequality. You can add the same value to both sides, and it's the same as if it were an equality. You have the addition property of inequality. That's your key concept there. And you have the addition property of equality. So in that little gold box for key concepts, if A is greater than B, then if I add C to both sides, you notice I'm offset here because it helps me think, is greater than B plus C. So the same concept, let's do this in numbers. So if 3 is greater than 1, then 3 plus 2 is greater than 1 plus 2. And we simplify 5 is greater than 3, which is true. And the same idea works for if A is less than B, then A plus C is less than B plus C. And y'all should be taking notes or working this, and I know it's in the book and I know you see it, but if you write it, it helps your brain remember it. And also in the book, if negative 5 is less than 4, then negative 5 plus 2 is less than 4 plus 2, which gives us negative 3 is less than 6, which is true. All right, let's go to example 1. Example 1. We're going to take x minus 3 is less than 5. We are going to solve, and we are going to graph. So since we have this negative 3, what do? We're going to add 3 to both sides. I'm going to work this like two problems. 5 plus 3 is 8. Negative 3 and a positive 3 is 0. X plus 0 equals 8. And we usually just ignore this, and we have x is less than 8. Now we have to graph it. 7, 8, 9. It's not an equal, it's just a less than, so that's an open circle. It's less than 8. So it goes that way. We check it by grabbing a number over here. I'm going to grab 6. Is 6 less than 8? Yes, it is. Okay. So 6 is less than 8. Now we're going to check our understanding. We have, this is the problem at the bottom of your page. M minus 6 is greater than negative 4. We're going to solve it and graph it. This is where you turn the video off and work the problem by yourself, and then you turn it back on and check. So go ahead, turn it off, and I'll wait. Okay, so you're back now. When we have this kind of issue, what do? We add 6 because we want to balance it. I will be doing this the slow way. M plus 6 minus 6 is going to be 0. It's going to be greater than negative 4 plus 6. I always mentally do a graph. And I go, I'm negative 4. I'm going to go plus 6. That gives me a positive 2. I know it's not much, but it helps me. So M is greater than 2. Now we're going to graph the solution. I'm going to use this one since I already have it, 2. So I'm going to go 1, 2, 3. Greater than, so it's an open circle. 2. M is greater than, so I'm going to go this way. I'm going to grab a number, let's say 4 over here, and I'm going to check it. Is 4 greater than 2? This is why we don't use pen. Yes, it is. Okay. Now we go to the top of the next page, and we have an inequality has an infinite number of solutions, and you can't check all of them. What does that mean? Excuse me. That means that when you look at the graph, not only is 7 a number here, or is 6 a number here, but so is 6.1, and 6 and 7/8, and 7.58923. But those are much harder to check when you get to a more complicated problem, so we go with whole numbers. So we're going to check. We'll look at this step 1. Check the computation, see if 8 is a solution to the equation x minus 3 equals 5. So we substitute 8 in there, and we're doing this one again, but we're putting an equal sign, right? So I did do that right. If we put 8 in, 8 minus 3 does in fact equal 5. This is one of those fact families, which also means that x minus 3 plus 3 is equal to 5 plus 3 because we added to both sides. That equals 0, so x equals 8, 5 plus 3. And then we can make it a greater than thing or less than thing. And if that's the case, now we have to check the inequality. We can't check the number. We have to check something less than that. They chose 7. So that's step 1 and step 2. So now we're going to go to example 2. Example 2. And y'all should be writing along with me. Solving and checking. You always want to check, because there's a lot of your problems I'm grading that if you had gone to check, you would have realized you had gotten it wrong. And then you could fix it before you turn it in. So our example, we're going to solve 12 is less than or equal to x minus 5. We're going to solve and graph. What do? Since we have this minus 5, we're going to add 5. I like to do it down below because that's one of the easy ways to add because I can see it better. This winds up with x because that cancels, right? Is less than or equal to 12 plus 5 is going to be 17. 17 is less than or equal to x. Let's graph 17, and then we want to go either side of that. 16, 18. It's less than or equal, so it will be a closed circle. X is greater than 17. 17 is less than x. So I'm going to read it this way to help my brain. X is greater than or equal to 17. Greater than this way, right? Even though it's a less than symbol, I'm reading it this direction, and it will still be accurate. So I'm going to substitute something in there. This is not quite, they substitute the equal part and then they substitute for the greater than part. If I substitute 17, because this is closed in, 17 is in fact equal to 17. I'm going to go with 18 and say, is 18 greater than or equal to 17? Is 17 less than or equal to 18? Is it? Yes, it is. All right, so now we have another check understanding. So this is where I want you to do the work. Solve, graph, and check. All three of those. Your homework is going to include a lot of that. When I worked them, because I did work all of them this time, I just had my whole paper divided into those 3 columns and lined it up that way and worked across, because for me they were pretty basic, and I think for you they'll be pretty basic. So what is your solve? N minus 7, pardon for the blurry, is less than or equal to negative 2. Here's another thing. You want to keep your negative close to your number, because a couple of times a pencil negative can get lost on a page and look like a smudge. If you don't keep it nearby, you will forget that that number was a negative. So you're going to turn off the video, and you're going to solve that, and then you're going to come back. I'll wait for you. Okay, so you solved it. What did you get? I'm going to add 7. We have n plus 0 is less than or equal to, here again, I'm going to do a little graph because we're going to need it in a minute. If I start with negative 2 and I go up 7, I'm going to get to a positive 5. So this would be my answer. See, I make it distinguished. Now I have 5, 4, 5, 6 is my graph. Less than or equal, so it'll be a solid circle over the 5. And n is less than 5. This is in a normal direction that we're used to, so we're going to go this way. Now I'm going to check. I'm going to grab this number, 4. Is 4 less than or equal to 5? Yes, it is. Okay, good job. Okay. Then we get to this key concept down here about subtraction. Well, we've just been doing some of that. It's the same thing again. If, go to a new space here, if A is greater than B, then A minus C is also going to be greater than B minus C. The other side, if A is less than B, A minus C will also be less than B minus C. And now I turn the page and I get a new page. And y'all should be making notes and working this with me. Example 3. I'm getting the light here. Using the subtraction property. So we're basically going to do the same things we've been doing. Y plus 5 is less than negative 7. Solve and graph. So what do? We have this 5 here, so we're going to subtract 5 from both sides. Sorry, my cat's getting into something. So y plus 0 is less than a negative 7, and a negative 5 will be a negative 12. That's the simplify. Now I'm going to graph. So I have a negative 12. Remember, this is on the other side of the 0. So the numbers get smaller as I go to the right, not bigger. And this will be negative 13. So y is less than negative 12. Less than goes that way. I use an open circle, and I'm going to do this. Let me check it, because I always want to check. Let me check 13. Negative 13. Is it less than negative 12? Yes, it is. Okay, sorry, I'm sarcastic. So now you're going to work this problem on the check understanding. t plus 3 is greater than or equal to 8. Graph and check. Solve, graph, and check. Whoa, sorry. Turn it off and work the problem, and then come back. Okay, what do? We subtract because we're working with subtraction, a property of inequalities. T. Now notice I curve my t. That's so that I don't confuse it with the plus. The distinction is critical because I'm grading 4 papers. This becomes 0. 8 minus 3 is 5. I'm going to just show you the math here. I grade 4 papers. Y'all come home, bring back somewhere between 20 and 70 problems. So I have 4 times 20 to 70, which gives me 80 to what, 280 problems to grade. My sister taught in a public school where she has not 4 students, but she had approximately 120 students. And if they all bring back 30 problems, how much does she have? She has 360 problems that she graded at least every other day, if not every day. So when you're having to grade this many papers, you don't get very long to do it. And if you can't read the writing, it's wrong. If you can't tell what the answer is because you crammed it way in the bottom of the page, it's wrong. So you have a little more grace from me because I don't have as many of you. But it will matter as you get older, especially if you go to college. So solve, graph, 5, 6, 4, 5, 6, greater than or equal, so it's a solid circle. T is greater than, so we're going to go this way. Let's pick 7. Is 7 greater than or equal to 5? Yes, it is. Ta-da! So now we go to example 4. Example 4. It's a real-world connection. Safe load. Maximum safe load of a chairlift is 680 pounds. The weight of the person on the lift is 124 pounds, and the weight of the bicycle is 32. How much more weight can the chairlift safely carry? So I have a chairlift, and it has a max of 680 pounds. There's the units. That means that this is safe. I want to have my weight be less than or equal to it. Because if I go over 680, then it's not safe. What am I actually carrying? I am carrying a person and a bicycle. The person is 124 pounds. The bicycle is 32 pounds. So my actual is going to be what? This is me not working it mathematically. So my actual weight is going to be the person plus the bicycle. But how much more can I carry? So I'm going to have a person plus the bicycle plus some additional weight, right? So my equation will be 680 is going to be greater than or equal to the bicycle, the person, plus the bicycle, plus the additional weight. They called it a W in this. They also made it backwards from that. So I plug in my real numbers, and I have 6, that's 80. 680 is greater than or equal to 124 plus 32 plus extra weight. I'm going to add this up here. 156. So 680 is greater than or equal to 156 plus W. I'm now going to subtract 156 from both sides. This will sum up to 0. 6 from 10 is 4, 5 from 7 is 2, 1 from 6 is 5. So what's my sign here? Greater than or equal. I carry that down. So to put it in terms that they have, the additional weight I can carry is going to be less than or equal to 524 pounds. You want to add the unit. So now we have their problem. Your baseball team has a goal to collect 160 blankets for a shelter. Team members brought 42 blankets on Monday, and they brought 65 blankets on Wednesday. How many more blankets must they donate on Friday in order to make or exceed their goal? So we want to make, that's equal to, or exceed, that's greater than, the goal. And the goal is 160. So we want to know Monday plus Wednesday plus Friday. I'm working it for you, aren't I? Is going to equal or exceed the goal of 160 blankets. So now you go ahead and work that, since I already set it up for you, and I'll wait. Turn it off. Okay, so now you're back. Monday is 42 plus 65 plus Friday is greater than or equal to 160. Our unit is blankets. This is going to be 40 plus 60 is 100. That's 7107 plus Friday is going to be greater than or equal to 160. I subtract 107 from both sides. Where did they work this in my book? They didn't. Okay. So this is going to go to 0. So I have Friday blankets is greater than or equal to 7 from 10 is 3. 0 from 5 is 5. 1 from 1 is 0. So by Friday, they have to bring more than or equal to 53 blankets. So that would be, in that kind of terms, at least 53 blankets by Friday to meet their goal of 160. Now we get to our problem solving. This is our exercises. I think I had almost everything for you. I will post this under the files, but just start off and assume we're going to do everything. Here's the catch. There's a couple of little bitty catches. Numbers 1, 2, and 3. They ask what number you would add to each side to solve it. They don't ask you to solve it. They just ask what number. What number do I need to solve it? So you don't have to solve it. You should be able to just look at it and tell. Numbers 4 through 19, solve each inequality, graph each inequality, and check. I suggest that you set your paper up this way. I'm going to work the first one for you. Number 4. The equation is x minus 1 is greater than 10. So if we add 1 to both sides, which you probably don't even need to write, I'm going to have x is greater than 11. I'm going to graph it. 10, 11, 12. It's greater, so it's an open circle. It goes this way. I check. Let's pick a number way out here. 13 is greater than 11. Yes, it is. So that's what you can do all the way, numbers 4 through 19. Then we get to, we'll come over here, problems 20 to 22. State what number you would subtract from each side. Want to subtract to solve. Do not solve it. Do not solve it. Just state the number. Then we get to 23 through 38. We want to solve, graph, and check. Just like we're going to do over here, we're going to do essentially 3 columns. Skip a space. Sorry, I grabbed my paper. Skip a space, number 5. Then you're going to do the same thing again. Skip a space, number 6, all the way down. 39, 40, and 41. Are word problems. You can put those all on one page, so just skip to another page because now we again have 42 to 44. State what you have to do, which is going to look like add 1, subtract 6, that kind of thing. And then 45 to 67, you solve. It does not say to graph. It does not say to check, but you should anyway. All right, I have a lot of places to go today, so get started with that. We're going to do more. I will check another thing. Remember, T, X, if you do a little thing, it won't be crooked with the sideways thing, and make sure that your 7s have a point to them. Your 4s are clear. Your 5s don't look like an S, etc. I'm going to post that too. That was what we were going to go over. So have fun. And I will check in with you later. Bye.